Hey guys, today's question is design circular DQ. In this question, we have to implement the myCircularDeque class, in which when the object will be created, this k will be passed, the size of the q will be passed, and we have to define the DQ. After that, we have to also write these 8 functions. Uh, to First function is to insert at front, insert at last, delete at front, delete at last. All the functions that are used in the DQ, get front, get rear. So DQ, first of all, DQ is a data structure based on queue, in which we can delete at both sides and also insert at both sides. Okay, in the queue we can also do these functions only once, because in the queue we can delete from the front and push at the rear side also. But in this DQ we can push at both sides also and delete from both sides also. So we have to write these 8 functions, the 4 functions to insert and delete, and after that getting the value which is present at the front and the rear, and these 2 functions to check whether the DQ is empty or not, or it is full or not. Okay, so what we can simply do is we can do this question by doubly linked list, but it will take too much space. And now we can do this question by using an array, a vector also. So we are going to use a vector, and we will have 2 variables to track the pointers at the rear value and front value. And what we will do, for example, when we talk about a queue, if we delete a node, when we implement queue by a vector or array, when we delete a node that is related from the front side, so we increment the front as front equals to front plus 1. Okay, and when we delete a node and we insert a phone node, we write rear equals to rear plus 1 and then insert the value at rear side if the queue is not full. So in this question, we have to add 4 more functions, that if we delete at the front side, if we insert at the front side, front will be front equals to, because front goes like this. Okay, front is at the left side and rear is at the right side. So front will be front equals to front minus 1 if you have to insert any value at front, and if you have to delete any value at rear, the rear will be rear equals to rear minus 1. You will just add these 4 lines, and also because we are implementing it via vector, we have to make it circular. So for making it circular, we will write the incrementation and decrementation, like front equals to front minus 1 plus k modulus k. If we have to write front equals to front minus 1, for example, if we have a vector, wait a second, 1 0 0 0, and let's assume this one is empty. Okay, this cell is empty. Let's assume front is here and rear is here currently, and we have to insert a value at front. So you can see we have to insert the value at this part, because this is currently, we can assume that this is the left of the front. Okay, because it is a circular DQ. So we will write front equals to front minus 1 plus k modulus k. By this method we can reach this index. For example, there are 5 elements, the value of k is 5 here. Okay, so if we write front equals to front minus 1 plus k, what will happen? Front is currently at 0, front is 0, so we are writing, wait a second, front equals to front minus 1 plus k modulus k. Okay, what will happen? As the k is 5, the size of the array, so, and front is currently at 0 at this place, so 0 minus 1 is, which is minus 1, minus 1 plus k 5, and modulus k, wait a second, front equals to front minus 1 plus k modulus k. We are inserting the value equals to front minus 1 plus k modulus k. Okay, so if front is currently at 0, what will happen? The value of k is 5, so this value will be 5 minus 1 4 modulus k, which will be this 4 here. Okay, so after taking modulus we will get that value. Okay, so now let's write function. First we'll declare the size. Currently, before inserting or deleting any value, size will be 0. Now let's take a global variable to use in all the functions. Also global variables rear -1 and front will always also be -1. You can write any value because the size is 0. When we insert a value first place, we will change the value as rear and front equals to 0. Now when this function will be called, we will make a vector of this size and assign to another vector that we will declare globally. So a vector, let's name it as vec of the size k and elements 0 or any elements, that doesn't matter. And now let's declare a global vector also, vector, and let's name it as v. And now just copy this vector from here, so v equals to vec. Okay, and also let's take a capital K for size that we declared here, so int equals to k. Now we have to determine these functions. First let's write the easiest functions, is empty and is empty is full. So if the total size of the queue is 0, then it is empty, so we return size double equals to 0 if it is empty. If it is full, then simply we will return, you can simply return size double equals to capital K. That means there are all elements size is k. Now after this, let's first create the insert front and insert at last. So we insert first. So first condition, if size is full, okay, if size double equals to k, or you can also write is full function replacing this value, but they are both same things. We will simply return false because we can't insert a value, as in the given question it is given if we are inserting a value and didn't do the operation successful or false otherwise. So we will return false if size is full and we can't insert that value. And in the else case, there are two cases. If there is no value, then we have to declare front as 0 and rear as 0. And if there are some values, if size is not 0, okay, if size not equals to 0, then what we're gonna do, we will increment the front, sorry, if front will be decremented as I explained. So front equals to front -1 plus k and modulus k. Just a second. Plus k modulus k. Okay. Now after that we have to insert the value at front. So v front equals to the given value. Okay. Just a second. In the else case, if the size was 0, there were no any element, so we have to change the value of front and rear to the first index and also insert the value at the first index, or you can say front or rear, any index, the given passed value. Now after this, we also have to increment size as we inserted a value, and we will return true, as in the given question we have to return true if the value is inserted successfully. Same, we have to create this insert last function. Let's simply copy this and change the values. Now if we are inserting at the last, the rear will be changed, so, and also rear will be incremented, not decremented. So rear equals to rear plus 1 modulus k, rear equals to rear plus 1 modulus k, and push the value at the rear index. This will be same, I guess. Okay. Now if we want to delete at front, so the base case, if size is 0, that means we don't have any value, we can't delete any value. So if size double equals 0, simply return false. Okay. And in the else case, there are also one condition, if size not equals to 1, because if size is 1, then we have to change the value, but if size not equals to 1, then only we can decrement front. Okay, so by the way, we can also not write, but let's take it so that it is more understandable. So if size not equals to 1, we will decrement front, we'll increment front, front equals to front plus 1. Okay, let's simply not write this condition to make it simpler. Okay, size minus minus and simply return true. Also, as we are deleting from the front side, front equals to front plus 1 modulus k, because we are deleting a value. Okay, it looks fine. If we are deleting from the last, again let's simply copy this. Okay, so if we are deleting from last, we have to decrement rear. So rear equals to rear minus 1 plus k modulus k. That looks fine. Size minus minus return true. Here also. Okay. To get front, simply if there is no value, we can't get the front value. So if size double equals to 0, the base case return -1 as given in the question. If the size is 0, then we have to return -1. Otherwise, we have to return the value present at the front index. So return b of front. Okay. Also, same in here. If size double equals to 0, that means we don't have any element. We can't fetch any value from the rear index. Otherwise, we will simply return the value at the rear index. Okay, looks fine. Let's run this. Let's see if there is any error. Okay, let's submit. Seems like my internet is slow. Okay, so the code is accepted. Thank you for watching.